Welcome to my third video on circuits. In this video, we're going to be discussing Kirchoff's law, specifically the loop rule. But before I get started, let me introduce myself. My name is Chris. I am the creator of all the videos here at Math Meeting. And if you need any extra help with your math homework, please send pictures to homeworksolutions@mathmeeting.com. The email's on the right-hand side of the screen, and I will get back to you immediately with a quote. Or maybe you just want live tutoring. I do offer live tutoring as well. Send me an email to livetutoring@mathmeeting.com, and we can set something up. But let's not waste any more time, and let's get started right away with this example. So here in this example, we have a basic circuit which is in series, and we're going to find the current running through this circuit. We're going to find the current running through the circuit, and notice how we have something a little bit different in this circuit. We have two batteries, we have two power sources. We have one battery over here and one battery over there. And because we have two batteries, we're going to use Kirchoff's rule, specifically the loop rule, to find the current going through this circuit. So what is the loop rule? So the basic idea behind the loop rule is that the sum of all the potential differences is equal to 0. In other words, the sum of all of the voltage changes, is equal to 0. So we're going to use this concept to find the current running through this circuit down below. So the first thing we have to do in order to use the loop rule is set the direction of the current. So step number 1 for using the loop rule is set the direction of the current. All right, and you are going to see that it doesn't matter which direction you set the current. If you set it for the wrong direction, you're just going to get a negative value later on. So you'll know that you just set it the wrong way and that the current is running the opposite direction. Because it's a little difficult. Notice how we have two batteries here. So when you have two batteries, it's not so obvious which direction the current is going. So let's say that the current is going to go in a clockwise direction, which means it's going to go up through this battery, it's going to go up through this resistor, it's going to go right through this resistor, right through this battery, it's going to go down through this resistor, and it's going to go left through this resistor. All right, and once again, this circuit is in series. Because this circuit is in series, we know that the current is never going to change throughout the circuit. So we know that the current going through this battery is going to be equal to I. The current going through this resistor is also equal to I. The current is never going to change. So the current through each one of these batteries and resistors is just going to be equal to I. All right, so now we can move on to step number 2. Step number 2 is to set the direction of the loop. All right, step number 2. Step number 2 is to set the direction of the loop. All right, and you can set the direction clockwise or counterclockwise. It doesn't matter. Once again, if you get a negative value for your current, you just know that your current is going the opposite direction. So let's say that our loop is going to go clockwise. So our loop is going clockwise. All right, and at this point, we're ready to use our loop rule equation. All right, so once again, the loop rule states that all of the voltage changes are equal to 0. So let's start with our battery. Notice how we are going in a clockwise direction. So we're going from the negative terminal of the battery to the positive. Negative to positive indicates a positive voltage change. So it's going to be a positive 24 volt voltage change. So we have a positive 24 volts. All right, moving up to our resistor. The voltage change is going to be the current multiplied times the resistance. And once again, since we're going in a clockwise direction, that means we're going with the current. If we're going with the current, that indicates a negative voltage change across the resistor. So we're going to have a negative voltage change. So, and the voltage is going to be the current times the resistance. So the current I multiplied the resistance of 10 ohms. Moving on to this 20 ohm resistor, Once again, we are going with the current, so it's going to indicate a negative voltage change. So the voltage is going to be the current times the resistance of 20 ohms. Moving on to this power source, this battery. For this battery, we are going, once again, in a clockwise direction, which means we're going from positive to negative. So that's going to indicate a negative voltage change across this battery. So it's going to be a negative 6 volts. All right, if we keep going clockwise in our loop, we come across this 40 ohm resistor. Once again, we're going with the current, so it's going to indicate a negative voltage change. So it's going to be the negative current multiplied times the resistance of 40 ohms. And doing the same exact thing with our last resistor, it's going to be negative I multiplied times 20 ohms. Multiplied times 20 ohms. And once again, all of these voltage changes, according to our loop rule, is equal to 0. All right, so now we have finished all of our physics portion of this problem, and we can just use algebra to solve for our current I. So the first thing we're going to do is add all of our like terms. We have a like terms of 24 volts and negative 6 volts. 24 minus 6 is equal to 18 volts. And we also have a negative 10i, a negative 20i, a negative 40i, and a negative 20i. Negative 10 minus 20 is negative 30. Negative 30 minus 40 is negative 70. Negative 70 minus 20 is equal to negative 90i. All right, so we have a positive 18 volts minus 90 ohms times our current is equal to 0. All right, and if we add 90i to both sides of this equation and then divide both sides by 90, we're going to get I is equal to 18 over 90, or 0.2 amps. All right, so our solution, our current running through this circuit is equal to 0.2 amps. And because our current is positive, that means we have chosen the right direction of this current. We know that the current is going to flow in a clockwise direction. So I hope this video gave you a better idea on how to use the loop rule. In my next video, I'm going to go over an example where we have to use 2 loops, and we have to use the point rule as well. So check out my next Kirchoff's law video if you want to keep on learning. Once again, I do offer homework solutions and live tutoring if you need any extra help. So send me emails if you are interested. Thank you so much for watching, and I will see you in my next video.